Howdy folks, welcome to the second installment of Factorising Quadratic Trinomials. Last lesson, or the very first lesson on Factorising Quadratic Trinomials, we looked at how to factorise using splitting the terms method with the P&S method. And then we looked at the shortcuts. So basically we looked at questions like this, where we had maybe x squared plus 5x, let's say plus 6. Okay, so just to review that, we did our P and S. Now our product always comes from the first number times the last number, which is 6, and the sum comes from that middle number of 5. So 6 has two combinations, 6 and 1, 3 and 2. Now this is one of the harder ones because actually 6 and 1 and 3 and 2 both make 5. But the only way to make 5 from 6 and 1, for example, would be 6 take away 1. So that doesn't work. So 3 and 2 are my two numbers. 3 plus 2 makes 5, 3 times 2 makes 6. And we said if it's a shortcut method, that's if it's a 1 or there's no number there, we can simply write x plus 3 and x plus 2. Really quick, really simple. I did tell you though that there were some cases where you would not be able to do that quick method, and that when you got your two numbers of 3 and 2, you would have to split that term in the middle. And that's what we're going to look at today. But before I do that, I'm just going to mention using this product and sum method, it's just simply like a guideline to get those two numbers that you're trying to times together and add together to get. If you're getting easy questions like x squared plus 5x plus 6, and you're feeling pretty confident with this stuff, really try hard to get the numbers without even writing the P&S down. So hopefully you'll get to a point where you'll see x squared plus 5x plus 6, and you'll simply be able to say, okay, it's going to be x plus 3, x plus 2, or maybe it might be x plus 6, x minus 1, you know, and being able to work that out. It's a really good thing to be able to do without having to write P&S down, but obviously if all else fails, P&S will work like a charm. Okay. So let's have a look at an example for today. So this is what I mean by having a question where it's not a shortcut method. There's no longer no number there. It's not just x squared plus 5x plus 3. There's a number in front of it that's not a 1. Okay, so we start the method exactly the same. Well, exactly, I mean, if you looked at that last lesson, it's exactly the same, okay, as splitting the terms. So my product is 2 times 3, okay? And the sum is 5. That's what I always kept on saying. It's that first number times the last number, because some people just think it's the last number, because in all those cases where it's x squared, it is the last number, but it's because you're doing the last number times 1. But in this case, it's 2 times 3, which is 6. Okay, same thing every single time. We're looking for two numbers that multiply to give 6, but add together to give 5. Well, we just did this one actually. Similar to this, we did 3 and 2. 3 plus 2 is 5. 3 times 2 is 6. They're my two numbers. Now, unfortunately, we can't just write down x plus 3, x plus 2. Okay, that would have given us the previous question. Okay, this time, because we've got these 2 in front of it, we need to split the terms, which means we're splitting the 5x up into plus 3x plus 2x in order to get those 4 terms that we looked at at the beginning of last lesson. So 2x squared plus 3x plus 2x and plus 3. And again, I get a lot of people being bothered by, well, what happens if I put 2 and then 3? Will that change? Okay, it will change slightly the way you factorize it and what's inside your brackets, which have to be the same, but the actual answer is identical. Okay, and we might even look at that if we have time. So 2x squared plus 3x, what goes into both? Well, x does. Okay, what goes out into both of those? So 2x times x, 2x squared, and x times 3. Then what goes into both 2x and 3? Well, I can't see anything, so that means that just 1 goes into it. 1 times 2x and 1 times 3. Remembering, like last time, these brackets here have to be identical if you've done it correctly, which luckily for us they are. So we get 2x plus 3 and x plus 1. How easy was that? What we might just look at, let's just reverse the 2x and see what happens. So we could do 2x squared plus 2x plus 3x plus 3. So all I've done is just reversed that around to see what happens differently. This time our factorising does change slightly, because obviously here we can see that 2x goes into both. We have x plus 1, and then 3 goes into both, we have x plus 1. The brackets are both the same, but what you notice, what's the difference between the first one and the last one? Well, you'll notice that here we had the 2x plus 3 inside the brackets. You'll notice the 2x plus 3 are now outside the brackets. Likewise, x plus 1 was out the front of the brackets. This time, that's inside the brackets. So it means exactly the same thing. We can put x plus 1, 2x plus 3, and both of those answers there are identical. Okay, because we're simply times the two brackets together, which, you know, the old saying 6 times 2 is the same as saying 2 times 6. They're both equaling to 12, so it doesn't matter which one they're around. And that's it, guys. That's as hard as it is. Okay, so we'll look at another 2 examples. Good idea. Pause it, see if you can get this one out. Okay, product and sum. Product is 3 times negative 4 is negative 12, and our sum is 11. Alrighty. So let's have a quick look and see. Two numbers that times together give 12, 11. Well, 12 got a lot of factors. We got 12 and 1, which I'm guessing 12 and 1 is going to work, because 12 minus 1 makes 11. 3 and 4 can't make 11. 6 and 2 can't make 11. Okay, so I've got my numbers. There's a number in front of the x squared, so we now are forced to split the terms. So let's rewrite it out. 3x squared, instead of having that 11x, I'm going to write in plus 12x minus 1x, or just x, minus 4. I'm going to underline the first and the second terms. Okay, let's have a look what goes into both. Well, 3x does, and we have x plus the 4, and then we have a negative 1, and then we're going to have x. Remember, negative 1 times positive 4 makes the negative 4, but remember also the other hint is the brackets have to be the same. Alright, so the last step now is simply just doing x plus 4 in brackets and 3x minus 1. Too easy, Campese. Okay, let's look at our very last question. Again, pause it, have a crack at it, see if you get the right answer. Alright, P and S. Well, our P is 6 times minus 1, which is minus 6. Our sum, now remember, a little bit struggle here because they can't see a number for the sum, but remember that's minus 1x. So it's negative 1. Okay, so two numbers times together give 6. We can use 6 and 1. Well, that can't make 1, can it? What about 3 and 2? Well, 3 and 2 are going to have to work in some order. How can I make negative 1? Well, minus 3 plus 2, or 2 minus 3. Okay. Alrighty, so let's split the terms. 6x squared minus 3x plus 2x minus 1. I like to underline the first pair and second pair as always, so let's factorize. 3x goes into both. We have 2x minus 1, and then we've got plus 1 goes into both. 2x minus 1, look at that, my brackets are the same, that is fantastic. Finish off with 2x minus 1, and then 3x plus 1. How good is that? Now, practice makes perfecto, so you got to go through and do lots of these types of examples. If you're running out of examples, remember you can actually just make up your own by doing things like this: 2x plus 4, x minus 6. Just expand it to see what the answer is, and then start from there. That's how I'll make up these questions. So, look, hopefully this was useful. Remember, if you have a number in front of the x squared, then you are forced to split the terms, and it's going to be the long method. If it's just an x squared question, okay, just get your brackets, get your two numbers in the brackets, and then you pretty much got your answer. Alrighty, practice. Best of luck.